In section 4.5, we're going to be looking at financial models and growth and decay formulas. So we're going to start with financial models, and there's three ways we can calculate interest. One is simple interest, which is the most outdated. It's just based on principal, which is the amount you invested. The yearly interest rate is decimal, and the number of years that you invest or borrow. Now, compound interest is more prevalent in today's society. There's kind of two ways we compound. One is for a certain time period, and it's given by this formula. It looks intimidating, but if you take your time and substitute the numbers and simplify as much as possible, it's not too bad. Most of the issues with this formula tend to be from the calculator. Okay, so hopefully with enough practice, you won't have those issues. But the variables in this formula are: A is your amount earned, P is your principal, so that's what you're investing, R is your interest rate as a decimal. Now, N is the number of times compounded in a year. So we'll talk about the different compounding methods. And then up here, your exponent, N times T, it's still, N is the same in both of these, and T is the number of time in years. So, if you think about it, if I'm compounding 4 times a year for 3 years, that's 12 compounds. That's where this comes from, okay? Now, continuous compounding is the amount is your principal times E raised to the RT, where R is your yearly interest rate as a decimal and T is your time in years. So we're going to look at calculating with both formulas using the time periods and the continuous compounding, and among other things. So let's just look at an example, and get your calculator handy as well. So depending upon your calculator, things may have to be simplified more or less. Okay. So if we invest $2,000 at an annual rate of 5% for 4 years, and first we're going to talk about semi-annual compounding. So this is twice per year. So in this case, N is 2, because N is the number of times compounded in a year. So if I substitute this into my formula, my principal is 2,000. It is 1 plus R as a decimal is 0.05 divided by 2, and then raised to the 2 times 4 power. Now, what I'm going to suggest you do is at minimum make this 8. Because when you start typing things into your calculator, if you don't do things properly, this exponent could be messed up. Now, depending on your calculator, you can probably enter this exactly as it is and then just put 8 here instead of 2 times 4. But, some people may need to simplify a little further. So what I suggest possibly doing is 2,000 times 1.025, sorry about that, raised to the 8th power. I went ahead and just took the 0.05, divided by 2, added my 1 to it, just to simplify things further. And then you can do the 1.025 to the 8th power, and then times 2,000. And so you should get $2,436.81. Okay, so that's compounding twice a year for 4 years at 5% interest. So if you're still taking time, just pause the video and just check your numbers. The only difference now in quarterly and monthly is N. So quarterly is 4 times per year. So n is 4. It's not going to make like, $100 difference, but it is going to be more than compounding twice a year. So nothing really changes except for n. So divided by 4 here, and then 4 times 4 here. So if you're compounding 4 times for 4 years, or 4 times a year for 4 years, that's 16 times. So I'm going to go ahead and take 0.05 divided by 4, and this time I get 0.0125 raised to the 16th power. So then I take 1.0125 raised to the 16th power, and then times 2,000. Now again, if you have a graphing calculator or one of the TI-30s that you can see everything as you type it in, you can type this in exactly as you see it. Okay, probably even do it up here and make this 16, but we'll work on that. So I get $2,439.78. So it's $3. Well, better than nothing, right? So about $3 more. And that's just compounding it extra. Now let's look at it monthly. So in this case, monthly, hopefully that it's 12 times per year. So n is 12. So I'm just going to, again, use this same formula. 1 plus 0.05 divided by 12 raised to the 12 times 4 power. Sorry about that. I'm getting ahead of myself. So 0.05 divided by 12 plus 1. So this one kind of starts getting a little bit smaller of a decimal each time. 0.0041. I'm going to go ahead and make it 417 to the 48th power. So I just rounded, I did the 4166666, so I just made it 417. I'm trying to get as accurate as possible. So I take that 1.00417 raised to the 48th power, and then times 2,000, and I get 2442.18. So again, that's almost $3 more than compounding it quarterly. So as you can see, it's more, which is always better, but it's not exactly, astounding amounts. But still, it's better, and over time, it makes a big difference. So that's your compounding for certain periods of time. Now, and again, I apologize, my notes got a little crumpled. Let's look at the continuous compounding for the same amount. So our continuous compounding formula is A equals P to the E times RT. So continuous compounding, we don't worry about anything but the rate and the time. So my rate is 0.05 and my time was 4 years. Okay, make sure I got that right. Yes. So again, depending on your calculator, you may want to multiply that just to make it easier on yourself. So that's 0.2. So then A is 2,000 E to the 0.2. So, with a graphing calculator, you can do 2,000, pull up E, type in your exponent. Sometimes you may need to do E to the 0.2 first, then times 2,000. These are all things we can work on in class if you have issues. But for continuous compounding, it's not much more than monthly, but it is still more. And again, over the course of time, it will make a difference. Okay. All right. So just check your work, make sure you're typing everything in correctly. So that's, finding certain amounts in your account in your investments when you're done. The other issue we can look at is time required to double or triple an investment. So if we want to double an investment, if it earns 5% compounded continuously, well, what we could do, like say we wanted to double the 4,000. Well, that means that I want my amount. I use this same formula. So my amount is going to be equal to 2,000 E times 0.05 T. And I'm going to show you why I didn't give an amount here to begin with. Because to solve for T, this is an exponential equation, I need to get e to the exponent by itself. And so what this always works out to be is this. This means double. If it was triple, I would just put a 3 here and solve for T. So what I have is this equation here, and then I'm going to change this to a logarithm. So ln of 2 equals 0.05 t, okay? That's what we do when we solve exponential equations. So then I take ln of 2, natural log of 2, and I get 0.693 equals 0.05 t. Divide both sides by 0.05, and I get about 13.9 is t. So about 14 years for an investment to double in value at 5%. Okay. So if you wanted to figure out how long it would take to triple, well, this would be a 3, so it would just be ln of 3 divided by 0.05. So to triple in value, it would be about 22 years. Okay, so, that's growth. Now, exponential growth and decay works very similarly. You're talking about either bacteria growth, population growth, things decaying. You use this formula right here. And A of t is the amount after so much time. That A sub 0 is always the amount you start with. And then it's E, R is the growth or decay rate, and T is time. So if I have a formula here, the size of a bacteria population is given by P of t is 200 e to the 0.6 t. I want to give the growth rate, and it's 0.6. Okay. If I want to figure out what will the population be in 3 hours, well, t is 3. So then P of 3 is 200 e to the 0.6 times 3. So again, a lot of this is putting things into your calculator correctly. So what I get for P of 3 is about 1,210 roughly. So after 3 hours, my bacteria would have grown from 200, because that's my initial amount. I start with 200, and after 3 hours, it's 1,210. So I'll give you time just to make sure that that's all good there. Part C, after how many hours will the population reach 300? So in this case, right here, this is my population after time. So what I want to do is I'm going to substitute in that 300. And then I'm going to solve for t because I'm solving for time. So I divide both sides by 200. So this gives me 1.5 is e to the 0.6t. Change to a logarithm. ln of 1.5 is 0.6t. So if I take the natural log of 1.5, I get 0.405. Divide both sides by 0.6. And I get about 0.68, so less than an hour. So, roughly an hour, 60 minutes. That's 3/4, 40 to 45 minutes. That's kind of what that represents, okay? The key is to know when you're substituting a value in for t and when you're solving for t. D is very similar to what we did up here. How long does it take to double? So when I talk about the population to double, I want to solve 2 equals e to the 0.6t because that means doubling. Okay, so I change it to a logarithm. ln of 2 is 0.6t. So 0.693 is 0.6t. So take that, divide it by 0.6. And it's a little over an hour. 1.16 hours is t. Okay, so that's what we're doing. And again, a lot of it is using formulas, using your calculator, understanding when to substitute in for certain variables, when to substitute in for others, and solve for certain variables. So, that's what we're looking at. So we will do more of this practice in class.